revisit any concept that we're discussing and the code examples as well. Perfect. So hey, everyone. Thank you so much for joining the echoAR workshop. Today, we're going to talk about augmented reality, virtual reality, and how you can build a cloud-connected app in 15 minutes or less. Thanks again for joining, and thanks for the event organizers for inviting us to run a workshop. We're echoAR. It's a cloud platform for augmented and virtual reality apps. We basically provide tools and network infrastructure for developers and creators like yourself to build and deploy 3D apps. We provided the hackathon organizers with a affiliated link in which you'll be able to register for our platform free of charge and get all our premium features. So definitely take advantage of that. And we'll also share this link to this recording later through the hackathon organizers. So I'm going to start by saying hello. I'm Alon, founder of echoAR. We're a New York-based company. I did a master's at computer science at Columbia University, specializing in AR and VR, and did my undergrad in computer science electrical engineering. So as you can see, a certified nerd and a big believer in the AR VR space. Feel free to write any questions in the chat as we go along with the workshop. And this should be as interactive as we can. Before we start, let's define some terms that I'm going to throw around a lot. So what is virtual reality? What's augmented reality? These are terms that you've probably heard. So VR or virtual reality is when everything around you is digital. You're fully immersed in a 3D environment, and everything you see is a CGI construct. So you're basically looking at a fully 3D world. Nothing around you is real, and your vision is being occluded through a headset that controls everything you see, basically projects it into your eyes, and sometimes also controls the audio that you hear. As opposed to augmented reality or AR, in which you still see the real world, and that world is being overlaid with 3D content and CGI imagery. You're looking at the world through some camera see-through, like a tablet or a phone, or an optical see-through, like a headset or some smart glasses. But basically, you still see the real world, and you have data on top of that. A really good concept to understand this is the amazing movie Space Jam, in which we have Michael Jordan being teleported into Looney Town. That's a really good example of virtual reality. Everything around him is a cartoon. He's interacting with bugs and the other Looney Tunes in their actual environment. And that is opposed to what we have later in the movie, in which we have Looney Tunes coming to us, playing around in the real world, playing basketball with us, interacting with Bill Murray. So that's the big difference between augmented and virtual reality. Either Looney Tunes is coming to us, or we're going to Looney Town. More real-world examples of this are something you're all familiar with. Pokemon Go, people are running around the real world, interacting with digital monsters that are not actually there. Or virtual reality, in which we have, like this example is Beat Saber, a game that you slash cubes based on the rhythm of the music. Everything around you is, again, just completely fake CGI, but you're fully immersed in this 3D environment. Another cool example of augmented reality is what I did back at my time at Columbia University. We took CT and MRI 2D scans, converted them to 3D models, build an application to put these 3D scans on a smart glasses for the physician to wear. These smart glasses are called HoloLens by Microsoft. And basically, the physician will be able to get this 3D reference map of the patient's anatomy in real time. It was a crazy experience. I would scrub into surgery. The physician will be able to get this scan floating above the patient, showing them how the inside of the patient is looking in real time. And they will be able to drive a catheter through their body based on these scans. An amazing experience. But for me as an engineer, I had to do something that I really, really hate. And that's waking up early in the morning. I had to go to the hospital at 6 a.m. to prepare for surgery, take those 2D scans, convert them to 3D models, put them on these smart glasses. And that took so much time. It was so frustrating. And as a developer, all I wanted to do is just two things. I wanted to manage 3D assets and deliver them to an AR device. And when talking to other developers who are building AR applications for retail and shopping and games and data visualization and training, they all said the same thing. There was no easy way to manage and deliver 3D data. But if you think about it, this problem was already solved for 2D. You don't need to be a web developer. You can to build a website. You can use something like Heroku if you're a developer, and you can get your cloud platform ready to go for web. If you're building a mobile app, you can use Parse or Firebase to power your application. So now we have this third iteration of content. We were in web, mobile, now immersive, AR, VR, 3D, call it whatever. And the question has to be asked, who's going to build that cloud platform for that? And you've guessed that that's us. So echoAR is that cloud platform for AR, VR, and 3D. basically providing tools and network infrastructure for developers and creators to build 3D applications. And later, we're going to see how you can do that, both from a non-code perspective and also a deep dive into coding. So that's us. As I mentioned, we provided an affiliated link for the hackathon organizers to share with you that you'll be able to register for premium features, premium access to our platform for free. So definitely check that out. And feel free to ask any questions in the chat if you have any. So let's define some more terms. So as you know, you don't need to be a web developer to update the blog post. You can drag and drop an image or video. Suddenly that appears on web and mobile. And if I'm in New York and you're in California and we're both watching an episode on Netflix, we automatically get the best streaming experience. We translated these concepts into augmented and virtual reality, basically providing you with a way to manage and deliver 3D data and get the best 3D streaming experience. And what's interesting here is, as opposed to like a image or web or video on the website that you can't move as a user, you can definitely move a 3D crouch across the room. And that needs to be updated in the cloud. That connection between content and space is really unique for AR/VR. So this is basically what we've built, that content management system and delivery network specifically for 3D. And this is our website where you can register for that to access. But again, I encourage you to use the affiliated link we shared with the hackathon organizers, so you'll be able to get premium features for free. And now we're going to dive into how you use that. So all you have to do is register for an API key. Once you register, you get this automated email with a project key or an API key, and then you can start building your app. So what you see on the screen right now, so on the left, this is the console, and on the right, you just see my phone. So you'll be able to see, like, this is, for example, is my API key. I'm able to load it here in the console, and I'm going to start with something super, super simple. I'm going to upload some content, some 3D content. I can do add to cloud, and then I'll be able to choose 3D models that we already have for you here. We have like some really cool 3D models that you can choose from totally for free, can stream to your devices. You can also search. We have the search engine that search and other content aggregators for 3D and grabs them into your project. And you can also upload files your own. Those could be 3D files, there could be videos, just an MP4 file, there could be images like JPEG or PNG. But I'm going to start with something simple, and I'm going to choose this Empire State Building, a tribute to our company in the city of New York. I'm going to choose this 3D model of the Empire State. I'm going to upload it to our cloud. What happens right now is that we take that 3D model, and it's the same 3D model as people use for 3D printing. We put it on our cloud. We build and compress and convert it. It works in Android, iOS, Magic Leap, you name it. Once it's done, we're able to see it here on the platform. And now let's start with something simple. So we have it here on the console. We see that 3D model. Now let's put it in augmented reality. So I'm going to open a sample app right here. This is a mobile native Android app that you can download right here in the downloads menu. I'm going to plug in my API key right here. It will stream the data from the cloud to the device. So it will basically stream the 3D model of the Empire State to my apartment. You can see my apartment right now. The camera will recognize that there's a floor here. So let's move the camera a little bit, recognize that there's a surface, a floor, and voila, the Empire State is here with me. I can walk around it, walk inside. Super, super simple. And all I had to do is put it on the cloud and automatically connects to our application. But what happens when you want to change this to something else? So instead of rebuilding your application or doing anything technical, I'm just going to go back to the console. I'm going to either edit or delete the entry, upload something else, and it will automatically update across platforms. Let's see how that works. So instead of this building, let's choose this building again. Same process occurs, posting it to our cloud, building and converting it to work on any platform out there. Once that's done, I'm going to open the exact same app that we just saw. Plugging in the same API key, streaming the data from the cloud to the device, camera scans the floor, and voila. Suddenly, instead of the Empire State, we have this apartment building. Super, super simple. Perfect. So now we saw an example of mobile, basically a mobile app that allows you to see augmented reality. Let's take it a step further. We worked with the companies, for example, that didn't want an app. They wanted a web experience. For example, an art agency, people would walk in randomly and wanted to see AR around them without installing an app. No worries. You can stream that to web as well, and that makes more sense for them for their project. What you do is you click on this button, this basically scan button. It will generate a QR code that you can scan. If you have a phone with you right now, scan it with me, and you'll see how we stream this building right now to your phones in real time. So scan this QR code with me. Most cameras have, for example, for Android and iOS, have their own, built-in QR code scanner. Scan this. It will redirect you to a website. You don't have to install anything. You can, again, scan it with your phones right now or just follow what I'm doing on screen. I'm able to see the building right here on my phone. I can press C in AR. The camera will instantiate. Again, no need to install anything. Camera will recognize the floor again. Now it recognizes the table, for example. And now I can put this 3D model on top of the table. So definitely check that out yourselves. So we saw mobile, we saw web. Let's see another example of a game engine called Unity that later in the coding portion of this workshop, we're going to talk a lot about. I open a sample up right here. This is a game engine a lot of developers use to build AR, VR apps across platforms. Again, camera instantiates, floor is being detected. And what's cool about specific Unity, like we have a SDK here that you can download, and we have a example app right here that you can just download and build. It's already pre-built, like a lot of open source code that we're going to talk in a second. We have more for Flutter and React and other platforms, so definitely check that out. So we see the camera recognizes the surface, recognizes the floor, putting that building that we all remember already. But now let's change things in real time. Let's do some animations, do some transformations. So I'm going to go back here. I'm going to click this small button right here that basically exposes the data panel. And the data panel will basically allow me to add data to that content. So let's click plus, and then let's add something like direction, and let's do direction equals right. Bam, suddenly it starts to rotate in real life. Unbelievable, like all I had to do is like click some button on the console, automatically it starts to rotate. If I think that it's too small, no worries, let's do here, let's go scale equals 2. Bam, suddenly it pops up twice the size. These are obviously like really simple examples, but it's to show you that you can like stream data in real time, you can change, you can enable and disable features remotely by adding text. This is a free text box, you can add anything you want, and then when you go to the code portion of the workshop, you'll be able to see how you can enable or disable any customized behavior that you want through keywords that you stream from the cloud. Let's delete this, it will shrink back. Super easy. Okay, so we saw mobile, we saw web, we saw Unity. What all these examples had in common is that all these examples basically relied on surface detection. The camera recognizes the floor, like a table or a chair. But another AR technology that we support is called image recognition. The camera recognizes an image and will overlay data on top of that image. So what you can do to start, you can click the same button of the QR code that we just had. And instead of doing see on the floor, do see on an image. Scan this QR code. And again, if you want, you can use your phones right now to scan this QR code. So I really encourage you to do that. Just scan this QR code from the screen. It will redirect to a website. Again, you don't have to install anything. But just remember that if you want to recreate everything I'm doing, you'll have to register for an API key. And voila, I'm keeping the phone in front of the QR code. And now the QR code acts as a target. Basically, the 3D model jumps out of my screen. Instead of being on the floor, now it's on top of some image. And I'm able to see this building basically pop out from an image. This image could be anything you want. It could be your business card, and then you overlay it with 3D models, or like a video of you talking. We sponsored a previous hackathon, and someone did a really cool project in which we put custom QR codes or custom images. People would scan them, see videos on COVID-19 and like informational videos on COVID-19, and then on the back end, they will actually scan how many people, they will actually count how many people scan those QR codes and basically give them information to enforce social distancing. That's a really cool example of a project. Let's see what other types of data you can upload. So we saw 3D models. Let's throw in just a video, so like for example, this cartoon, just an MP4 file. I'm going to throw that in. Same process occurs, but now we're actually converting the video as opposed to a 3D model, just making sure that it's optimized for augmented reality. Once that's done, you're going to see the video on the console as well. Same process. Let's scan this together. And again, you can scan this with your phone. Redirecting to a website, you don't have to install anything at this point. And then just keep your phone in front of the QR code, and that will basically overlay that QR code with a video. So let's see how that works. There we go. We see a cool video just playing on top of that. Super, super simple. Let's see that. Okay, I'm going to start the video right here. What else can we do? So we can actually have custom images. So let's do that as well. So let's plug in, maybe you'll do even the same video just in a custom image. So here in the target, I'm just going to choose on an image as opposed to a specific, like anywhere. So let's do on an image, choose some specific image. Let's do this image. Make sure that your image has a lot of contrast and like for the camera to recognize it. Like it can be just like a blue screen or something like that. It has to be like a high contrast image and a lot of colors. Let's upload that. Same process occurs. Now we're just like adding in, image integration. Once that's done, we're going to see that video appear in the console as well. Let's give it a sec to convert. And then same process occurs. You'll be able just to scan it and see it in augmented reality. Super easy, super cool. And again, everyone without even technical knowledge can do that. Maybe let's delete this one. And let me upload another type of content. So I can upload this fox and now put it in a specific location. So that's the third type. So we have to put it on a surface, put it on an image, or put it in a specific location, which means I can put it in New York, for example. I can build an app that if you open it in New York, you're going to see the Empire State Building. But if you open it in San Francisco, you're going to see the Golden Gate Bridge. There you go. Same process occur, but now we're just adding that extra data of location. Super easy. If there's any questions, feel free to add them in the chat. Let's see how we can see the video on the image. So let's scan this QR code again. Again, redirect to a website. You don't have to install anything. Camera would instantiate. This might take a minute, another minute. Let's open that. And there we go. So suddenly we have this 3D model, this video overlaying a custom image as opposed to what we had earlier, which was a QR code. Perfect. So let's see, now that we saw how you can add content, how you can manipulate content, how you can add data, let's play around with the console a little more. So we saw the downloads menu that you're able to download an app or all our SDKs for all the different platforms, some example codes that you can that are ready to build. You can swap themes, which was cool, right? Dark theme, light theme, dark being the default. Help menu is really, really an insane resource for you all. It links to our documentation, which is literally a step-by-step guide of everything I did so far. I'm going to share the link here as well for you to play around with it. Caroline is asking, how do I get it on my phone again, like from the computer, not the scan? So in order to get it to your phone, we use the QR code, for example, to have your phone browser be directed to that experience. So when you upload a 3D model, you have these QR codes ready to go. If you want, you can go to the console through your mobile phone and then just click buttons in the console on the mobile. Can you have a 3D animation? Yes, you can. When you upload 3D models, if you have a 3D model that you want to upload, you can upload pre-animated ones, and that will work the same, and it's pretty cool to see. You can upload FDX files. They usually have pre-built animations. So we have the documentation here. I shared the link here in the chat. It's a step-by-step guide, but it has like really cool, GIFs and just to show you how to recreate everything I just did and how to integrate, how to use the web console, how to use our API, how to use all the different SDKs for Unity, ARJS, React, Swift, you name it. So definitely check that out. Other things that you can do here is access our GitHub page. This page has so many resources for you. Basically, a lot of free projects that are already open source that you can use. So for example, let's open a few of them and play around with them. So let's do the face change, the living room, the COVID-19 one. Let's do, what else is cool? Let's do the remote work, and let's do Freaky Museum. So all of, and I'll share this right here as well. There you go. So these examples are already pre-built projects that you can use with echoAR. For example, if you want to do some really cool face change, like face filtering kind of thing, you can do that. There's a really cool project here that basically shows a living room inside a living room that you can watch a movie in AR. Another example is the COVID example. Later, we're going to rebuild this together. Here's another example of remote work that you can put someone in augmented reality with if they have a scan. Freaky Museum is cool, bringing images to life, right? So definitely check those out. We have a question, can you show gesture control? So I don't have a demo for gesture control, but you can definitely implement that if you have, if your application supports it. So in Unity, for example, you can add gestures on pinching the screen. For example, what I did, I clicked on the screen, suddenly a 3D model appeared on the phone, on the floor. I can use in the web ones, I can pinch the screen to make it bigger and smaller, stuff like that. So that's pretty easy. If you want hand recognition, which is a little more complicated, you just need to make sure that your AR SDK supports that. Andrea is asking, if my test device doesn't support any Surface display, should it work in other devices, which it can't? So the thing is, on any Surface, that's just something that you define in the console. Your device being supporting for AR or not, you just need to make sure that when you do CN AR, for example, when I did the web example, you'll be able to instantiate a camera and your camera would see 3D models on the floor. Most devices, they do support that, but just make sure that you have, if it's iOS, that it's enabled with ARKit, and if it's Android, it's supported with ARCore or Google Play services for augmented reality. Kirat is asking, in Unity, can you pin a content to always be spawned at a specific location? Yeah, so basically, as long as you manage that logic in your app, and we'll do that in Unity in a sec, you'll be able to make sure that this fox, for example, only appears in New York, but you'll have to build that logic into your app. For iOS implementation via the SDK, how would you make the model stay in one spot? So that's basically how it works. So like when you stream 3D models to iOS, if it's for Unity or through Swift, that model is being anchored to a specific location based on surface detection. So as long as you have, you click something and then you see it, you should be able to anchor it to the floor the same way I just did. Check out again our documentation. There's a link here for Swift integration. Just read through that. It will guide you how to build that specifically in iOS. It shouldn't move with the users. If you program the app correctly, it shouldn't. And if that's still the case, use our example here with Unity and AR Foundation and build it for iOS, and then your problem should be solved. So I really recommend using this project because that has all their configurations already preset. Perfect. So we saw our documentation, we saw GitHub. You definitely join our Slack channel. Our support team is there to help you, and I'll hang around there as well to answer any questions if you need help with debugging and stuff like that. So you have a link here. You can always email us or tweet us. Super easy to get to reach us. You can also asking what team. It doesn't matter. You can put your team hackathon or just leave it blank, and that's fine. It doesn't matter. How could this be applied to web app? So Rebecca, check this out. So if you click on this button, for example, this gives you a direct link to the model. And specifically in the model, this is what I when I scan that QR code, that redirect me to this website. I can share it right here. But basically here you can have, for example, the web app, you can have an iframe and then have that iframe show this website, which this website basically redirects to a 3D model. This short link basically allows you to see that 3D model. If you're opening it on mobile, you'll be able to see it in AR as well. So you can integrate a lot of 3D models into your web app if you want. You can also share all these things on social media and mobile social networks like WhatsApp. Okay, so we saw how you can create, sure thing. So we saw how you can upload 3D models, how you can manage data, how you can have all these resources to help you out. Let's dive into more stuff that you can do. The data page is really cool, allows you to control data remotely. Remember, we talked about adding data to specific 3D models and specific content, but you're also able to add global database. For example, we supported a project that did a scavenger hunt murder mystery thing for augmented reality, and they had 3D content associated with different scenes, like crime scenes, but they also have global data that is associated with all scenes. So that's what you can do with the global database. Payments is a cool page, shows you how much API calls you're making, storage, bandwidth you're using. And if you're using the affiliated link from the hackathon, you're going to get this tier for free. So definitely check that out, our premium tier for free. Location is a cool page, shows you the distribution of content. Remember, we added that Fox in New York. So there you go. We have that pin for New York. It shows you the distribution of content around the world, the servers that it's using to stream your data. Security is a cool page, allows you to add team members to your project. So if you have a project and you want others to join it, basically allow them to also add models and stuff like that, you can just add them here. Insights is a cool page. Basically allows you to, again, see how many API calls you're making, bandwidth that you're using, the storage that you're making, see how people are using your content. So for example, we just streamed that apartment building. So there we go. We have this spike in usage. And here we have some more history on the project itself and how it's being used. Super useful. Users is really cool. Shows you the distribution of users, where your users are coming from. Now it's empty because I just uploaded data right now, so it's pretty empty. Tutorials is a really cool and useful page. Links to our documentation, links to a bunch of frequently asked questions. Shows you open source examples like this solar kind of solar system example for education that are all open source and you can play around with them. So definitely check them out. Link to our GitHub, link to our documentation again. Inspiration page is my favorite page. Shows you so many examples of AR, VR to get inspired and build things that are similar, like the art project that I mentioned, the murder mystery game, or some cool project we did for Verizon. There are so many cool examples here of augmented virtual reality for healthcare and training and military use and in shopping and retail and data visualization and games, obviously. And here's a few examples of COVID, like the COVID tracker that I mentioned that people did during other hackathons. So definitely go to this page to get inspired. Here's a chemistry one that uses image recognition with QR codes. So definitely check those out. They're really, really cool. And if you build something with echoAR, we will make sure to feature you on this page as well. So definitely check that out too. Here's a really cool project that people did recently with patient data being shown in augmented reality based on face recognition. Perfect. So far, we saw a lot of things that you can do with a console. No code was necessary at all. Now we're going to transition to the part that we are doing some coding in Unity. So if there's any questions so far, please write them down in the chat. OK, so this is Unity. It's a game engine that a lot of developers are using to build AR/VR applications. It uses C# as the coding language, but if you know Java or other object-oriented programming language, you should be OK. After you install Unity, make sure to download the Unity Sdk right here. It's going to be a file. You double-click it, and then it automatically adds everything you need to your Unity project. You have this echoAR folder. And then when I go to examples, there's this empty scene that you see right here. This scene is completely empty. There's nothing here. When I go and touch the echoAR game object, I'm able to add my API key. So let's do that. Blue water 6. I'm going to press play. And now 3D models will appear out of thin air. They will stream from the cloud to the device, and then we're able to see them here. So let's see that. There you go. We see the building rotating. We see the video playing. The video is actually playing in my ears, so let's maybe delete that. See, I'm removing it from the console. Automatically, it will be removed from my scene in Unity. The fox is being occluded by the building, so let's move it. We already know how to do that. Go to the console, go to the data panel, add some, let's say, x equals 10 feet. Bam, suddenly it moved in real time. Very cool, very, very easy way to move data around. When I stop the application from running, everything disappears. So this is basically to show you how your application will actually conserve a lot of memory, because the 3D models are not actually persistent on the device. Only when you open it, the device will stream from the network. This means your app will be really, really small. It's just a camera, and then data will stream every time the app is running. If I press play again, everything will return. Everything will stream back from the cloud. The cool thing about this is that you can see that it remembers the state. We basically have what we call a stateful CMS, a stateful quantum management system, that remembers the state of data. It remembers that the building is rotating. It remembers that the fox is 10 feet away from the building, is able to reinstate that scene the way you built it. OK, now let's move on to some custom changes that we want to do. So let's delete the building, put the fox back in the center. And there we go. So we have the fox right here, sitting in center, called Arctic Fox Posed. Now, let's say we want to change something. So every 3D model that is streamed with echoAR has a custom behavior script attached to it. This is a script that you need to change if you want to add any features, any capabilities, and you can basically change that and have your entire logic persist in this script. So let's see that script, and let's change it a little bit together. So as I mentioned, C#, this is the Unity standard format. It has two specific functions. One is the start function, evident by its name, instantiates when you start the application. And we have the update function, which is really interesting. This is a function that happens every single frame. Remember, you're coding in 3D now. That means there's a scene being rendered. There's frames, like a video. So this function will actually be called every single frame. It's like a while true loop, or like a infinite for loop that happens all the time. You need to make sure that this function is really optimized, and like remember your CS classes that you need that complexity of this function to be really OK, because if this hangs or crashes, your entire application hangs or crashes. So let's look at the start function. Let's see what we have. So we're adding some script, the remote transformation script that handles the rotation, stuff like that, to our entry. We have a snippet of code that we're going to focus right now, and that will be like a feature that we want to add, for example. So here we're asking, does this entry, like this fox, does it have any additional data? If it does it have a name? If it has a name, set the name of the object to that name. OK, let's see how that works. So right now we don't have a name, so let's add a name. Does anyone have a good name for a fox? Let's call him Kevin. Kevin. There we go. And now when I press play, the fox will restream into the platform, into the game engine, and voila, suddenly it's named Kevin. Super easy. We're able to change something through the code and through the data that we just streamed remotely. Perfect. Now let's say I want to change something. Again, I want to change its name to Sam. It didn't change. Why is that? Because the code that we ran for the name change is in the start function. It only happens when we start the application. So if I unstart it and start it again, the data will stream again. That start function will run again, and we'll see that too. Perfect. Now it's called Sam. Super easy. Now let's change the code a little bit. Let's say we want that change to be happening in real time. So I'm going to take this snippet of code, and I'm going to put it in the update function instead. So now every single frame, we're going to ask, do I have a name? If I do, change that name to the name that I have. So let's see how that works. Let's press play again. Data will be streaming again from the cloud to the game engine. We'll see the fox named Sam. But now when we change it back to Kevin, bam, suddenly it's named Kevin automatically. So this is obviously like a simple example to show you how you can change things in real time, how you can have data on the console affect things in Unity. And you can basically use that to enable or disable if flows, enable or disable features, control features. Really, you're only limited by your imagination. So this was a simple example. If you have any questions, feel free to write them in the chat. And if not, I'll just move on to some more complicated example. So let's delete this from let's clear the console. Let's upload new content. Let's do that. So I'm going to upload a specific 3D file that I have right here, a 3D file of our blue Earth. And I'm going to add a CSV and Excel file with it. This is basically a file that has all these preloaded keys like scale to direction right in it. And then that will be uploaded with the 3D model and basically allows you to basically pre-add data without needing to type it in manually. So I'm going to do that, uploading to our cloud, same process that we're already used to. And now it's also setting the data. I'm also going to swap the custom behavior script under the hood. So let's swap that and then have some new functionality that we didn't have before. And then we're going to analyze the script together to see that functionality. Perfect. So we have the Earth right here. We have all the data automatically thrown into the console. And now let's go through our new script. So this is, again, the new script, C# Unity format. We have suddenly a new array here of all the continents. We have some dictionary, some data structure. We have the start function that looks exactly the same as it did before. And we have the update function, which now is much more interesting. Let's go through it together. So every frame we're going to ask, do I have any additional data? If I do I have an additional data called scale? If I have a scale, let's parse that value into an integer. Now we say, OK, let's iterate over all continents. Let's check, do I have an additional data that is associated with the name of a continent? Here we have, if we do, let's add that, let's parse that as a number. Take that number and ask if I have a graph. Let's set that size of the graph to that number. If I don't, let's create a graph. Let's create the cylinder, give it a color, give it a name, give it a size, give it a location, add some text to it. And if I don't have anything, let's just remove that graph. Let's see how that works when we press play. So I'm going to press play. Data will stream from the cloud to the device. And automatically, you're going to be able to see that. There you go. Voila. We're able to see the building rotating, and we see all these graphs. Anya is asking, how do you implement echoAR in a mobile app? So you can do that in Unity, and then in Unity, you press build setting or build and run, and then you can build this app as a as a mobile app automatically. Unity is being used to generate mobile apps, basically. And you can also do that, as I mentioned earlier, with like web and mobile, like the things that we saw earlier. As I mentioned, again, if you go here to downloads, you can use this Unity plus AR Foundation code. Maybe I'll share that specifically with you here to automatically, it's already pre-built. You just need to build that, add that your API key and then build that project, and you have a mobile app with echoAR. And as people mentioned here in the chat, just go to our documentation and go to the section on Unity, and that will help you build a mobile app. OK, so we see all the data right here. We see this really cool COVID visualizer showing how many COVID cases were in each continent. Now let's change things in real time. If I change Antarctica from 1 to 8, bam, suddenly we see the graph spikes. Really cool. If I delete Antarctica, disappears. Very cool. Similar example just to show you how things could update in real time and how you can build this really cool visualizer in virtual reality or augmented reality. What you can do now is take this code. Oh, it's already open source. And built on top of that, build an app that basically takes, I don't know, integrate a third-party API. For example, the WHO, the World Health Organization, has some API for how many COVID cases there are out there. Do RESTful API calls, change these values remotely as opposed to manually with like changing the table. And then this graph will actually update with real-time data. How cool is that? But the cool thing is, again, that if you stop the app from running, everything disappears, right? Everything clears to the memory. Perfect. If there's any more questions, please write them down in the chat. If not, I'm going to just continue to recap what we see so far. How do you change data remotely? So that is exactly what we saw earlier. If you use the console, you're able to add data here, like to change it here. And if you want to have the data changed through an API call, go to our documentation, go to API data, and then you're able to request data or post data through just an API call. If you request this API call, give it your API key and just the key and value, they'll automatically be added to the console without actually using the console. So there's a lot of RESTful API key calls here that you can just add, automatically use them. I'm going to share it as well. Perfect. So let's go back to the slides. So we talked about how you can build applications for Android, iOS, Unity, web, Magic Components, you name it. Content creators need no technical skills to do everything we did in the first part of the workshop was very no code-ish. Then we built, store, and deliver those assets to headsets and mobile devices everywhere. Developers obviously save time and money in building their app backend. You don't have to build anything specific, and you don't have to like hook up servers and everything. We do that for you. You need no technical skills if you're a content creator, and companies can scale data all over the world. So you can change properties of the model using keys. Yeah, so like, for example, we had the property of rotation, and that made it rotate right or left. And I can change the property of rotation to be left or right or whatever I want, and then that will automatically change the way it happened. Remember in the beginning of the workshop, I had building on the floor. Suddenly I added data in the console, automatically out of thin air, it started rotating. That was an example of me changing data remotely, and then the app will fetch that data, and the feature was rotation, for example. Is it possible to use an app in offline mode? No, because like the entire point is to stream data from the cloud to the device. Like if it's in offline mode, you're not going to be able to see data. If you want, you can save some of the 3D models, but then you're losing the point of having an actual app. Like if it's in offline mode, then it's more like a prototype as opposed to like a fully fledged app because you don't have like servers connected to it or something like that. But good questions. We talked about use cases. We talked about surgery. We talked about interior design, ads, tourism, shopping, games, obviously. So many really cool, amazing things. We saw the inspiration page in which you're able to build, you're able to see all these projects that people build with echoAR and without it. So definitely check it out as well. And I'm really, really excited to see what you're all going to build and basically, again, let your imagination run wild. Other us as a company, we won a bunch of awards backed by some of the top investors in the country, like Imagine Ventures, Techstars, Verizon, and we're there for every major tech event. So once things go back to normal, if you're there at some event, find our team, say hello. But let's say that we're the track that powers all the horses in the space. So it doesn't matter if you're building applications for Android or mobile or web or iOS or Unity or HoloLens or Magic Leap, you can use echoAR to stream data and allow those apps to run and make them online apps. Make sure you register in our website or use the affiliated link we shared with the hackathon organizers for you to get premium tiers for free. Thank you so much for being in this workshop. Feel free to reach out through our Slack channel and ask any questions. Really, really excited to see what you're going to build. And the last thing I would mention is like we're sponsoring one of the prizes. So if you're building something really cool with echoAR and submit it for judging, you're eligible to win the echoAR challenge, basically win that award. So definitely build something cool. It can integrate any of the things that I showed you so far, and then you're going to be eligible for that award. Any questions, Lucy? Can we act like contributors? Do we constantly keep making apps or so? Yeah, I mean, obviously, you can use this to build as many apps as you want, and the minute you register for our platform, you can build as many apps as you want with our tech. Rebecca is asking, will we have free access to the echoAR even after the hackathon? Yeah, so we are extending, we're extending specifically for the winners, but everyone else who wants the free access to continue, you can always email us, and we'll just mention that you got to us through Tech Hacks, and we'll happily extend that for all of you. Is there a guide on how to write code in Unity for models? Yes. So again, our documentation, maybe I'll send you specifically that Unity link. There's literally Unity/edit code that will allow you to see how you can write and add things for Unity. If you want to send me a project to echoAR, yeah, that's true. Just make sure you click the right thing on dev post. Perfect. If there's any more questions, feel free to write them here. If not, feel free always to reach us through our Slack channel. So remember, in order to get to our Slack channel, you just go to the console. Where's the console? I don't have it open anymore. Yeah, there you go. Click here, redirect to our Slack, and you'll be able to ask our support team for help. Start building amazing things. I can't wait to see what you're all going to build. I'm super excited to see that and judge that competition. Thank you so much for being in this workshop. Stay safe, healthy, and sane, and start building. Thank you so much, everyone. Have a good one. Bye-bye.